Yeah. Is the audio fine? So just confirm. Is it fine now? Yeah. So let's continue basically. So this is lecture number 4 of multivariable calculus. So in the last lecture, we were talking about Euler's theorem and also Taylor series. Okay, of course in 2 dimensions. So in today's class, we'll put forward, like we'll solve an example hopefully on Taylor series, and then we'll move to the concepts of maxima and minima in multivariables, of course. Okay. So before I quickly start the session, let's give a quick update. So this is the Telegram channel QR code for getting all the updates of this channel. Okay. So you just have, if you have any, if you just scan this, and if you join the channel, you'll be in regular with the sessions and you won't miss out any important content. Okay. And again, this is my Telegram channel where you can join if you want to get in touch with us. This group is basically maintained by me and my students as well. Okay, of PW. And let's see, before I start, I would also advise you to install PW Unity so that you have all your doubts or polls. Important point, you can track your complete status of the year at a particular slot, okay, at a particular location. And how to utilize this is, before asking a doubt, if you type exclamation doubt and if you enter the doubt, then it would benefit you. Similarly, if you write exclamation notes and if you enter the notes, then again it could greatly help you. Okay. So in the last lecture, we were talking about homogeneous functions. So we talked about homogeneous functions of multivariables in general. Okay. And also we got Euler's theorem. So we have seen the advantage of this Euler's theorem. It helps us to reduce the calculations to a great extent. And we have also worked on Taylor series actually. Okay. So Taylor series, of course. So we have seen the Taylor series for functions where this function is depending on, at least in this case, 2 independent variables. Okay, so we have dealt functions which are dealing with 2 independent variables actually. And let's see, in last class we have given the expansion for this Taylor series. Okay, so in today's lecture, what we are going to do is, we are going to cover this one example basically on the Taylor series, then also the concepts of maxima and minima in multiple variables or in multiple independent variables, and also we are going to work on the constraint maxima, which is optimization, of course, and we are going to work on Lagrange's multipliers in today's class. Okay, so let's continue. Before I start maxima and minima straight away, I would like to tell one example. Okay, the Taylor series expansion of the Taylor series expansion of f of x comma y is equal to, let's say you take one simple function, e power x times ln 1 plus y. So if you expand this function in terms of x and y's, okay, so let's say about 0 comma 0, about origin, if you expand this, how the series is going to be, let's check it up. Okay, maximum minimum already completed, not single variable, multivariables. Okay, single variable I have already taught, I know, but this is multivariable calculus. Clear? So let's look here, it's not completed, we are going to start today. Okay, Shravan. So let's see, as per the definition I have given you, f of x is equal to f of a comma b plus 1 by 1 factorial times fx at a comma b into x minus a plus y minus b times of the first derivative of f with respect to y at a comma b plus 1 by 2 factorial, I'll just write 2 terms, x minus a whole square fxx a comma b plus 2xy fxy a comma b plus y minus b whole square. This is just like a quick review of what we have done yesterday, a comma b, and so on. Okay, so similarly for the third degree and all, you can write the series. So according to this expansion, let us try to expand this function and let's see how we have the series expansion for that. Okay, which is containing the terms containing x and y, of course. Okay, so let's see. Therefore, f of 0 comma 0, since you want only coefficients of x comma y, you don't want anything like x minus a or y minus b, let's put the values of a and b to be zeros in this. So f of 0 comma 0, if you put x equal to 0 and y equal to 0, e power 0 times ln 1, which gives you 0, of course. Okay, then what is fx? Fx is equal to e power x into ln 1 plus y. So if you replace 0 comma 0 here in this point, for this function also at 0 comma 0, which gives you 0 actually. Okay, and what about fy? Fy is, so if you differentiate this function with respect to y partially, e power x is a constant, derivative of ln 1 plus y is 1 by 1 plus y into 1. So if you put at 0 comma 0, so this function value at 0 comma 0 is 1 actually here. Okay, so you have a 1, of course. Similarly, let's calculate fxx. Okay, So if you calculate fxx, differentiate this with respect to x once again. So again you'll get e power x into ln 1 plus y. Then the derivative at 0 comma 0 is 0 again. Okay, because if you put y equal to 0 and x equal to 0 here, it's 1 into 0, which is 1 into log 1, so which is 0 of course. So fxy. So if you differentiate this function, so let's say this is fy. If you differentiate it once again with respect to x, then you'll get fxy. So the function is e power x by 1 plus y of course. Okay, because this is already fy. If you differentiate it once again with respect to x, you'll get fxy of course. And when you're differentiating this complete function with respect to x partially, this 1 by y, 1 plus y is a constant. So ultimately the derivative of e power x will be e power x. Okay, and if you calculate this value at 0 comma 0, this value is also at 0 comma 0 of course. Okay, so then if you simplify this, if you put x equal to 0, it's like 1 by 1, so which is 1, which is the same thing. And fyy, so if you calculate fyy, let's check what is fyy, derivative of this function with respect to y partially. So e power x is constant, so minus e power x by 1 plus y whole square. So when you put origin here in this place, this value is minus 1 of course. Okay, because 0 is 1 plus 0 whole square is 1 and minus e power 0 is minus 1 actually. Okay, I just want you to do the third derivatives also, because I just want to teach you something important. So if you calculate f triple dash of x, so which is again the same function, so at 0 comma 0 it's going to be 0 f x y y, let's say. Okay, so you have f y y to be this function. So if you differentiate this with respect to x once again, you will get minus e power x by 1 plus y whole square. Okay, so this at origin gives you minus 1, you know. Okay, so now let's also calculate f xx y of course. Okay, so f xx y, because you have f double x y in the third term, so you already have f xx. So if you differentiate with respect to y, you have e power x by 1 plus y actually here. Okay, because this can be written as yxx, doesn't matter, its derivative is always smooth. So e power x by 1 plus y. So if you put origin here in this case, again you substitute origin, so this value is going to be 1. And what's going to be fyy? So this fyy is going to be the third derivative with respect to y. If you differentiate this, it's like e power x to e power x by 1 plus y whole cube, correct? Because minus into 1 plus y whole power minus 2, so minus 2 into 1 plus y whole power minus 3, the derivatives you can do partially. If you replace origin in this, so here also you replace origin, the answer is going to be 2 actually. Okay, so because we are expanding about the point 0 comma 0, so this value is going to be 2. Now let us use all these coefficients in formulating this. Okay, so we get the Taylor series expansion. So let's do that. Therefore f of x comma y is equal to, now let's see, f of a comma b. So what is f of a comma b? It's 0 straight away. Okay, so 0 plus 1 by 1 factorial times of, then a value is 0, so this term would simply give you x. Okay, because a is 0, so x into what is the value of fx actually? So fx value at this point is 0, so this term is 0, x into 0 plus y minus b into fy at a comma b. So fy at a comma b is 1 actually. Okay, so this is 1, so this is the first term, plus 1 by 2 factorial into x minus a whole square, so which is x square, into the second derivative of this function at origin is 0 of course. Okay, so this is 0 plus 2xy into fxy at origin is plus 1, so this term is going to be plus 1 plus y square into fyy at 1, which is minus 1 again. Okay, so this is minus 1 of course, plus 1 by 3 factorial times of, let's see, x minus a whole cube, so which is x cube, into f triple dash at this value, so f triple dash of x at this origin is 0, so this is 0 plus 3x square y into fxxy, so fxxy at this point is 1 of course. Okay, so this is 1 plus 3xy square into fxyy, so fxyy at this point is minus 1, so minus 1 plus y cube times f triple dash of y is 2 actually at this point. Okay, and so on. In fact, you can keep generating this series actually like this. Okay, so you can keep generating the series. Now if you simplify this a bit, you will actually end up with, if you simplify this, f of x comma y is equal to, this is origin, then 1 by 1 factorial is 1, x into 0 plus y, so this complete term gives you a value y actually, okay, plus 1 by 2 times of 0 into x square is 0, 2xy minus y square. So you have 2xy minus y square, of course, plus 1 by 3 factorial. So 1 by 3 factorial is going to be 1 by 6 times 0 into x cube, 0, 3x square y minus 3xy square plus 2y cube actually here, okay, plus and so on. This series will go actually. Now why I am simplifying this is I just want to show you that this series can be obtained in an alternative way, which is very simple. Even this is not complicated, but it's slightly calculative, okay. But in the other way what we write, that you will see the same series will get we can achieve this series with very ease actually, okay. First of all, is this clear to all of you? Did you all understand till this point? Please confirm quickly. Yes or no? The only thing I have done is I have calculated these derivatives at this point for this given function. You know how to differentiate a function partially, so I have differentiated accordingly, and I have substituted. I have ended up with this series. Is this clear to everyone till this point? Panjal, Shravan, Sugi, Arvind. I could see only these names. Rest were on the top, maybe. Everyone. Yes. Did you all understand? Basically, we have calculated the partial derivatives of the function at that particular point origin, and we have substituted in the Taylor series. Okay. The only thing I have done is I have done this partial derivatives little faster. That's all. Apart from that, I haven't done anything. Okay. Fine. Every one of you, just type it in the chat box. Is this clear till this point? It's the function, so I started with the first order derivatives, then went for the second order derivatives, and then went for the third order derivatives. That's all. Okay. Then let's see. So if you just for one last time, if you simplify this, f of x comma y is equal to y plus 2 gets cancelled, so you have xy minus y square by 2 plus 3 by 6, so 1 by 2, which is x square y by 2 minus xy square by 2 plus this 2 will cancel this 3 times, so y cube by 3 plus and so on. So this is what you got. Okay, so this is the final series. So let's see, you can also achieve this series by a different technique. Look, or if you had little idea, I've given you something actually. F of x comma y is e power x times ln 1 plus y actually. Okay, so what is the expansion of e power x? Let's see. The expansion of e power x is 1 plus x by 1 factorial, the Taylor series expansion obviously, plus x cube by 3 factorial and so on, into log 1 plus x. I have given you the expansion for log 1 plus x in the single variable calculus. So x, okay, this is ln 1 plus y, so y minus y square by 2 plus y cube by 3 minus y cube by 4, I mean y cube by 3 minus y power 4 by 4 plus and so on. If you multiply these two things, okay, so if you multiply these two things, let's see how the series progresses. So first 1 into, let's consider up to third degree because I have shown you till the third degree terms. So 1 into this complete expression gives you y minus y square by 2 plus y cube by 3 actually. Okay, so this is the term. Then plus x into, again up to second degree because the total degree is only up to 3, so x into this first two terms, so plus xy minus xy square by 2. Okay, then plus x square by 2 into only the first term, x square by 2 into the first term. Okay, then x cube by 3 factorial, here there is no constant, here after every term will be fourth degree term actually. Okay, but since I have calculated only up to third degree, so I can prove only up to third degree, I am calculating this. Okay, if you see, these two series are actually same, y and y gets tallied, plus xy minus y square by 2 minus y square by 2 plus x square y by 2 plus x square y by 2 minus xy square by 2 minus xy square by 2 y cube by 3, and it is y cube by 3, and hereafter every term will be of fourth order. So that's how, if you know the Taylor series expansions of simple functions, generation of Taylor series for multivariables is sometimes very easy when you follow these techniques. Clear to all of you? Yes or no? Please type it in the chat box. Okay, did you all understand this technique? Basically this is the expansion for the log 1 plus y, and this is the expansion for e power x. If you multiply and consider the terms only up to the third degree, then both the expressions will actually match. Okay, did you all get this or not? Please type it in the chat box. Everyone, Sugi, Shravan, Panchal, Arvind, all of you basically. Okay, fine. So let's, okay, so I hope it's clear. So let's move on to the concept of maxima and minima. Okay, because I thought of discussing one example so that you'll be comfortable in doing the things. Okay, then let's see concept of maxima and minima. So for finding the maximum values of, for finding the maxima and minima, of course, so for finding the extreme values of, for finding the extreme values of f of x comma y. So here directly I would give the procedure. Okay, so f of x comma y. So in case of single variable calculus, what you do is you're going to calculate the first order derivatives and equate it to 0, like f dash of x is equal to 0. Okay, but here this function, when it involves two independent variables, you have to, in general we are discussing again only in the two variables, which is in the Gates-Silver's limits. So when you have these two variables, of course we can differentiate this function in with respect to x and also with respect to y. Okay, so we have two first order variables actually in this case. Clear? So to differentiate this, step 1, what we do is, step 1, calculate p is equal to fx and q is equal to fy. Okay, so let's say this function is equal to z, for example. Okay, so z is equal to some function of x comma y. So calculate p is equal to fx and q equal to fy. So this is the partial derivative with respect to x and partial derivative with respect to y, and equate it to 0, and equate it to 0. Then ultimately when you solve these two equations, then you can get n number of stationary points. Like again in single variable calculus, let's say if there is a cubic function. Okay, if you differentiate a cubic function, the cubic function gets converted to quadratic function, and if you equate a quadratic function to 0, you'll get two values of x. Okay, so which means you have two stationary points. But instead of cubic function, if you differentiate a biquadratic function, let's say if there is a fourth degree function, okay, or maybe if there is a trigonometric function, then the number of stationary points you get for that particular function depends purely on the function. Okay, similarly here the number of stationary points you get will plainly depend upon this function f of x comma y. Okay, so when you have certain stationary points, let's pick one of the stationary point and let run the analysis. Okay, so let x naught comma y naught be a stationary point. So we'll see at different stationary points how do we get. So be a stationary point actually. Okay, so be a stationary point. Then let's see step 2. Step 2, calculate r, which is fxx at the point x naught y naught. Yes is equal to fxy or fyx at x naught y naught. Okay, and t is equal to fyy at x naught y naught. So at that stationary point, calculate these values r, s and t, where r is the second derivative of f with respect to x, s is the first derivative with respect to x and then second with respect to y, or maybe vice versa. T is fyy actually. Okay, so which is dou square f by dou y square at that particular point x naught comma y naught actually. Okay, so now we can decide again. So case 1, if r is positive and rt minus s square is also positive, this implies f of x comma y has minimum at x naught y naught. This has minimum at x naught y naught, and the minimum value is, so what's the minimum value? And the minimum value is f of x naught y naught actually here. Okay, so this is f of x naught y naught. Similarly, case 2, if r is negative and rt minus s square is less than 0. Okay, in such case, sorry, this is positive always, so rt minus s square is positive. This implies f of x comma y has maximum at the point x naught y naught, maximum at the point x naught y naught, and the maximum value is f of x naught y naught obviously. Okay, so this is x naught y naught. If you remember, in single variable calculus I have drawn the graphs and shown you the function has to be from increasing to decreasing in order to have if from increasing to decreasing in order to have a maximum okay. Similarly, decreasing to increasing if you want to have a minimum, all these things, okay. There it's possible to draw the lines and all very easily because it's a 2D, but in 3D drawing the planes and the curves is slightly complicated, so that's why I'm not doing it as of now. So you can see this are greater than 0, but these are the mathematical checks to observe the location or the existence of maxima and minima, of course, okay. Then case 3, if RT minus S square is equal to 0 actually, okay, then X0 Y0 is said to be a saddle point, actually here. Saddle point. We have seen about saddle points in 1D, of course, in a single variable calculus, but in general, if this is equal to, this is negative, this is negative, please correct it, this is negative. So if RT minus S square is negative, so then X0 plus X0 comma Y0 is basically a saddle point, okay. So please correct this, it is negative. And case 4, if second derivative is 0, and basically at saddle point, I just want to make one more comment here. So at saddle point, neither maximum nor minimum exist for f of x comma y, okay. So neither of this maximum or minimum exists for this function. And case 4, if RT minus S square is equal to 0 actually, okay. So let's say if RT value is exactly equal to S square, then we can't comment on the function. Okay, so we can't comment on the function, of course. We can't comment on the function, and further analysis is needed, is what we mentioned, okay. So further analysis is needed to comment actually, okay. So normally, which is not within the again syllabus limits of gate examination, but in general, if RT minus S square value is exactly coming out to be 0, then you can't comment, okay. But if it's a saddle, you can tell at that particular point there is neither maximum nor minimum, okay. So this is the working procedure in order to have. It is more or less similar to what we did in single variable calculus, but since this is being multivariable, we rely on the value of RT minus S square, which again talks about the descents, okay, which again you'll see later maybe, but these are the working conditions to discuss about the maxima and minima of these two variable functions actually. Is this clear to all of you? Please type it in the chat box. Just a minute, I'll have some water. So please type it in the chat box. Is this fine to every one of you? Did you all understand the working procedure to identify the maxima and minima in case of two variables? Yes, everyone. Quickly type it in the chat box. Just a minute. Let me. Yeah. Okay. Fine. The comments are coming right. Yeah. There's a blocking in between. So let's see. Let's work out an example to understand. So example, find the extreme values of the function. So one very nice function which I take generally is f of x comma y is x power 4 plus y power 4 plus 4xy minus 2x square minus 2y square. Okay, so let's say if you have this maxima and minima of this function. Okay, so Hindi classes schedule as of now this is only for pure English batch, so we are doing it as of now, but we will do the things later. Okay, maybe parallel we are running, but maths is not in Hindi as of now. Okay, so let's see. This is the function f of x comma y is x power 4 plus y power 4 plus 4xy minus 2x square minus 2y square. Okay, so let's calculate. See the working procedure for the calculation of maxima and minima of this particular case. So let's see solution. So let's now follow this step by step procedure. Okay, so we have the function z is equal to, or basically this function f of x comma y is equal to some function of x comma y. Okay, so let's check. Let's follow the procedure step by step. So first, calculate p equal to fx and q equal to fy. Okay, so p is equal to dou z by dou, or dou fx by dou x. Let's write this, which is fx. So if you differentiate this, you have 4x cube plus. So you have, I have taken a lengthy equation so that you can understand. So this is fx 4x cube, derivative of y power 4 with respect to x. This is purely a function of y, so it's valid only for two variables or more, only for two variables. Okay, because if you go beyond two variables, there is generalization in terms of vectors in ND space. Okay, which is not present in the GATE syllabus part. So that's why I'm stopping it with the two variables thing. Okay, so generally, if you see, normally if you see, it has, if you have in last class, I think I have told, normally if you expand this using Taylor series, the first derivative would be something like this is f of x plus gradient of f of x plus t p. P is the point about which you are expanding this series. Okay, so transpose is what you have, plus and so on. So in general, this is actually the vectors and normally the multi-dimensioning which we see in optimization techniques, again in multi variables, not even in single, in multi variables. So but I'm not considering these things because this is not in the syllabus. Okay, but this is the actual, and the this gradient when you take for this vector, you'll get it something called tensor, which is a matrix, and that's called the Hermitian again. Hessian matrix. Okay, so let's see, if you differentiate this 4x cube, then plus 4y minus 4x. So this is p, and what about q? Dou f by dou y, which is equal to f y actually here, then 4y cube plus 4x minus 4x actually. Okay, so this is the p and q values. So do we need to buy course, or this channel will be sufficient for CS GATE preparation? See, basically, to be frank, like here the content will be taught, but again all the practice tests. Okay, then after what do you say, this weekly test, DPPs, all these things will be regular only in the batches, of course. Okay, but for content learning, this could be good enough. Okay, Piyush. So let's see if this is p and if this is basically q. So equate these things to 0. So p is equal to 0. This implies 4x cube plus 4y minus 4x is equal to 0. So this, if you wipe out a 4 from all the equations, x cube plus y minus x is equal to 0. So this is equation number 1, which you get when you make p equal to 0 actually. Okay, then second, q equal to 0 implies, so if you equate this equation, 4y cube plus 4x minus this is minus 4y, right? So minus 4y, of course. So 4y, because this is 2y square, so 4y. So minus 4y is equal to 0. So this implies, so if you calculate 4, of course, if you cancel 4 all over, then it gives you, this equation becomes y cube plus x minus y is equal to 0 actually. So this is equation 2, of course. Now when you equate p equal to 0, you got this equation, first equation, and when q equal to 0, you got the second equation. Now the idea is to solve these two equations. That's it. Okay, so how to solve? Let's see. So first, if you try to solve this, we have two equations, x cube plus y minus x is equal to 0, and we have y cube plus x minus y. Y cube plus x minus y is equal to 0 actually here. Okay, then how to solve this? Let's see. Let's use the substitution method. This y can be actually written as x minus x cube, correct? So replace that y here. This implies x minus x cube whole cube plus x minus x cube is equal to 0. So if you simplify these equations, let's see, x and x gets cancelled. So from this complete equation, if you take x common, you have x cube times of 1 minus x square whole cube minus of minus plus x cube is equal to 0. So this can be written as x cube times 1 minus x square plus 1 is equal to 0. But we are staying only in the real plane. We are not moving into the complex plane. So we will see only the real solutions of this. So this implies x cube is equal to 0. So which implies x is equal to 0. And 1 plus 1, 2. X square minus 2 is also equal to 0. So x is equal to plus or minus square root of 2. Okay. So these are the 3 roots you have because it's of order 3 in general in terms of y. And you can see there are 3 roots. So what are the stationary points? That's the question now. So if x is equal to 0, let's see, at x is equal to 0. So therefore first point, at x is equal to 0, y is also 0. So one stationary point is origin 0 comma 0. Second stationary point at x is equal to, let's say, plus root 2. What about y? Y is equal to root 2 minus root 2 whole cube. So this tells you square root of 2 minus, this is root 2 whole cube, which is 2 root 2. So square root of 2 minus 2 root 2 gives you minus root 2. So therefore this point tells you x comma y is equal to root 2 comma minus root 2. Similarly, at x is equal to minus root 2, because that's one more possibility here. So at x equal to minus root 2, y is equal to minus root 2 minus root 2 whole cube. So which gives you plus root 2 actually. Okay, correct. So minus, this is 2 root 2. So yeah, correct. So this implies, or therefore x comma y is equal to minus root 2 comma root 2 actually. Okay, so therefore we have three stationary points actually. Okay, so what are the three stationary points? Origin, root 2 comma minus root 2, and minus root 2 comma plus root 2 actually. Okay, so therefore the stationary points are, therefore the stationary points are, you have three stationary points in this case: origin, root 2 comma minus root 2, and minus root 2 comma root 2 actually here. Okay, so now first thing we have done is we figured out stationary points. So this function has got three stationary points. So we achieved this step 1 successfully. Okay, so calculate this r equal to, this equate to 0, so you get the stationary points. So you got three stationary points. Now your job is to analyze the nature of each and every stationary point. Okay, so let's do that. So first let's consider stationary point 0, or basically 0 will consider last. There is a reason, I'll show you. So stationary point root 2 comma minus root 2, let's say. Okay, let's work out what is the nature of this stationary point actually. Okay, then let's see if you calculate r for this function. Okay, so what is the value of r? So this is p. So p is this function actually, 4x cube plus 4y minus 4x. If you differentiate this once again with respect to x, you will get 12x square minus 4. Okay, what is s? You differentiate this function with respect to, y, then you will end up with only 4. Okay, so this is 4. And what about t actually? So t is differentiating this with respect to y once again, 12y square minus 4 is what you get. So 12y square minus 4. So when you do rt minus s square, so what is the value of rt minus s square? Rt minus s square is equal to 12x square minus 4 into 12y square minus 4 minus s square, which is 16 actually. Okay, so at that point, root 2 comma minus root 2, check the value of small r and also rt minus s square. Now the value of r and rt minus s square gives you the nature of this stationary point actually. Okay, so at root 2 comma minus root 2, r value is equal to, so here in this place, if you put x equal to root 2, it gives you root 2 whole square is 2. So 2 12s are 24, 24 minus 4, which is 20. So this is positive clearly. What about rt minus s square value? Let's check it out. So if you put x equal to root 2, this value is 20. If you put y equal to minus root 2, this is also 20. So 20 into 20 is 400 obviously, minus 16. So 384, which is also positive actually here. Okay, because if you put x equal to root 2 and y equal to root 2, this becomes root 2 whole square. This is minus root 2 whole square, which is again 2. So 20 into 20, 400 minus 16, which is 384, which is positive. So therefore, at root 2 comma minus root 2, r is positive, and also rt minus s square is also positive. Okay, so rt minus s square is also positive. So if r is positive and rt minus s square is also positive, can someone tell me what is the nature of this stationary point? What is the nature of this stationary point actually? Can someone tell me? This r is positive and rt minus s square is also positive. So can someone comment on the nature of this stationary point from the cases I have given you? So can someone quickly comment on what is the nature of this stationary point, square root of 2 comma minus square root of 2? Minimum, right? So it has a minimum at that particular location. So therefore, f of x comma y has a minimum at root 2 comma minus root 2. Okay, and what is the minimum value? Minimum value is equal to, so let's say what is the minimum value. So the function, what is the function actually? This is the function that we have. Sorry, this is the function. So in this function, put x is equal to root 2 and y is equal to minus square root of 2. So if you put x equal to root 2, this is root 2 power 4 gives you 2 square. Okay. So the first term is 4 plus y power 4. If you put y equal to minus root 2 whole power 4 is again plus root 2 whole square. So which is again plus 4. Then minus 4 into xy. So x is plus root 2. Okay, plus 4xy. So plus into 4. Then x is root 2, y is minus root 2. So root 2 into minus root 2 gives you minus 2. So this is minus 2, of course, minus 2x square minus 2y square actually here. So if you simplify this, then ultimately 4, 4, 8 gets cancelled. So this is minus 8. So therefore, minimum value of this function is equal to minus 8 actually in this case. Okay, so the minimum value of this function is 8 and that happens at this point root 2 comma minus root 2. Clear to all of you? Yes or no? Please type it in the chat box. Is this point clear? The minimum value is minus 8 because these conditions are getting satisfied and the point is root 2 comma minus root 2. So this function has a minimum at square root of 2 comma minus square root of 2 and the minimum value is minus 8. Okay, so this analysis, is this clear to all of you or not? Please type it in the chat box. Yeah, everyone. Okay, 7 stars. Panjal, Shravan, Piyush. Yeah, okay. So I hope this is clear to all. Then let's see. It's fine, right? So let's inspect the other stationary points also. So let's inspect stationary point. So second stationary point we are taking up is stationary point we are taking up is minus square root of 2 comma square root of 2 actually. Okay, so let's calculate this. So if you calculate this, okay, so if you calculate this, let's see, we have r value is equal to, so r value we have calculated 12x square minus 4, it is common, 12x square minus 4, s is equal to 4 and t is equal to 12y square minus 4. Now, what is r at this point? So at minus square root of 2 comma root 2, r is equal to, so if you put x equal to minus square root of 2 whole square, this is again 20. So which is positive, of course. Okay, what is rt minus s square value? Let's see, 12x square minus 4 times 12y square minus 4 minus 16 actually. Okay, so rt minus s square. So if you put r, s and t only symbol, right? Yeah, we check the values of this rt minus s square at this point. Okay, so we check it. Clear? So let's say this is, if you put these values minus root 2 comma plus root 2, it is again positive. So this is also positive. So clearly here also we are getting a minimum. Therefore f of x comma y should have minimum at x is equal to minus root 2 comma y is equal to root 2 actually here. Okay, so if you change this point, our x comma y is equal to x comma y is equal to minus root 2 comma root 2, of course. Okay, so let's say we have this. Then let's see what is the minimum value. Minimum value, it should be minus 8. Okay, because there can be only one minimum. Fine. So in this case, if you replace x equal to minus root 2 and y equal to plus root 2, minus root 2 whole power 4 is like 2 power 4, which is 4, plus y power 4 is actually root 2 power 4, which is 2 square, which is 4, of course, plus 4xy term. Okay, so this is plus 4xy. So plus 4xy minus 2x square minus 2y square actually. So again, if you simplify, 4 minus 8 gets cancelled, you have minus 8. And anyone without even doing this simple calculation, you can tell the answer is going to be, sorry, what is 384? This value is 384. Yeah, of course. If you see, this value is 384, the same thing, and it is positive. Okay, so this is positive. So basically here, anyone without doing this analysis also, you'd have told the answer would be same. The reason for that is this function, whatever you have, is symmetric about x comma y. Okay, which means if you replace x and y, this function do not get disturbed. Yes or no? Correct? even if you replace x comma y, this function do not get disturbed actually. Can you observe this? If you replace x with y, it is y power 4, it is x power 4. So summation same. If you replace x and y, x into y and y into x, it is same. So minus 2x square minus 2y square. Even if you replace these two, the function would be same. So when this function is same, whatever might be the nature of stationary point for a comma b, the same nature would be there for b comma a as well. Okay, so that's why this function has two minimums here. Okay, so this is minus 8. So let's look at the last stationary point 0 comma 0, which is a bit easy to work out. So stationary point 0 comma 0 actually. Okay, so if you do this, let's see, r is equal to 12x square minus 4, s is equal to 4, and t is equal to 12y square minus 4 actually here. So if you put 0 comma 0, so let's see, at origin the r value is minus 4, it is negative. Okay, so first of all, second, at 0 comma 0, what is the value of rt minus s square? So what is the value of rt minus s square? Let's see, rt minus s square. So this is rt minus s square expression. So if you put x equal to 0 and y equal to 0, this is like minus 4 into minus 4, 16 minus 16. So this is exactly 0 actually in this case. Okay, so got it? This point is exactly 0 of course, and so we cannot determine the nature actually at this point. Okay, so just a second guys, I think I have altered the conditions here. This is 0, yeah, 2. This is 0 if rt minus s square is equal to 0, then this is called saddle, and if it's negative then you can't decide. Yes, please change this 2 points. Okay, so please change these two. If rt minus s square is equal to 0 and rt minus s square is negative in this case, then obviously this you cannot comment on the function, but if it's is equal to 0, it's called saddle. Yeah, second derivative is also 0 at that point too. So this is the case of a saddle point. So please correct this. That's why generally if I don't derive, these are the mistakes that I do sometimes. So this is 0 and this is less than 0. So ultimately this point is actually a saddle point. So therefore 0 comma 0 is a saddle point actually in this case. Okay, so this is a saddle point, means if you try to plot this function will have a saddle at the origin of course. Okay, so if you want you can use a 3D plotter and you can check. Normally at the origin this function will take the shape, or the curve will take some shape like this. Okay, so this function at origin maybe here, so it's of a saddle shaped function, clear, in the xy plane. Okay, so please change these 2 points. I think I have misplaced the equal to sign and less than sign. So this is equal to 0 and this is less than. If it's less than, then you cannot comment. Yeah, of course. So let's work out one example so that you can have some idea. So solve this question. The total cost of the equipment in terms of operating variables x and y is C total. Cost total is 2x plus 12,000 by xy plus y plus 5. The optimal value of CT rounded off to 1 decimal place is dash. Come on, solve this question. I'm giving you time, integer, and 150 seconds. Okay, so yeah, 150 would be good enough. Solve. Come on, solve this question quickly. Zero is what you're getting the answer. So optimal value of CT is 0, which means you get it for free. Is that 2? Optimal cost equal to 0 means no cost, you're getting it for free, but that don't happen, right, generally. One. Maybe let's check. Do the question. Okay, solve it. Just now you have seen the technique to solve, so work out something. Ashwini, Shravan, Sayan, Panjal, 7 stars, all of you. So do it quick a bit. Okay guys, done? Anything apart from 0 comma 1? Any other values? So anyway, meanwhile you enter the answer if you can solve this. Look, let's see how to solve this question. So solution, given CT is equal to 2x plus 12,000 by xy plus y plus 5, of course. Okay, and you want what is the total cost of equipment of operation, the optimal value of CT, and obviously if you want to buy some equipment you will do it at minimum cost. If you want to sell it, you will sell it at maximum cost. Okay, so let's see what is the optimal cost. Means basically the cost means you're actually buying it. Okay, so let's see. So ultimately the first thing, step 1, let's calculate it. So let's call this to be a function f of x comma y, so that it would be easy for the terminologies. So p is equal to fx, which is 2, because derivative of 2x with respect to x is 2, plus 12,000 by y is a constant. Okay, because 12,000 by y would be constant if you are differentiating with respect to x. So derivative of 1 by x is minus 1 by x square, and these two terms are zeros. Okay, then q is equal to fy, so which is minus 12,000, or 12,000 by x is constant, in that case 12,000 by x into minus 1 by y square plus 1 actually. Okay, so this is the case, p equal to this function and q equal to this function. So the first thing you have to do is equate the first derivatives to 0 and solve for x comma y values. So if you equate it to 0 and if you equate it to 0, then you can get the values of x comma y. So did anyone solve these two equations and did you get the values of x comma y? Come on quickly, please type it in the chat box. Did any one of you solve these equations and did you get the values of x comma y? Any one of you? Yes, no, something? I know some of you would be stuck at these equations, but there's a high chance that some of you can actually solve these equations. Okay, so let's see how you can solve these equations. So again, the same technique. What is y from this equation? You know, y is equal to 12,000 by 2x square. Okay, so this is the equation. So this is 6,000. So y is equal to 6,000 by x square is what you get. Okay, 6,000 by x square. So 2 is equal to, so ultimately this if you bring this term to the right hand side, 2 cancels 6,000 times, so y x square, so y is equal to 6,000 by x square. This is first option. Now substitute this y equal to 6,000 by x square in this equation. So we get, if you send this minus 1 to the other side, we have minus 12,000 is equal to x times y square, because this xy square is purely in the denominator. If you bring this term to the right hand side, then xy square is equal to 12,000. So x into, what is the expression for y square? 6,000 whole square by x square is actually x power 4. Okay, so you have x power 4 actually, because 6,000 whole square divided by x power 4. So we can solve this equation. Maybe we can cancel this square and cancel this 2 times, and with that remaining 2 you can cancel this 3,000 times actually here. So this tells you x power 4 minus 3,000 x is equal to 0. So one solution is ultimately x equal to 0, or x cube is equal to 3,000. So x equal to cube root of 3,000 actually. Okay, so x equal to cube root of 3,000. So these are the two values that you get, of course, in this case. Okay, so let's see. These are the two values of stationary points where you get in this particular question. Okay, so x equal to 0 is one solution and x equal to cube root of 3,000 is the other solution. Is this clear to all of you till this point? Yes? Come on, quickly type it in the chat box. Can you all get this? We got x equal to 0 or x equal to cube root of 3,000 actually. So these are the two solutions which you are getting in this case. Okay, everyone comment in the chat box. Yes, did you all achieve till this point? Okay, then let's calculate what is the corresponding values of y. Okay, so if x is equal to 0, okay, so if x is equal to 0, then we have y is equal to 6,000 by x square. Okay, so it's not defined obviously, so this division is not defined, so this x equal to 0 is just a solution, but mathematically it cannot offer a solution. Okay, so let's see. For x is equal to cube root of 3,000, cube root of 3000. What is y? Y is equal to 6000 by x square. So which is 3000 whole power 2 by 3 is what you get. Okay, so this is the function 6000 divided by 3000 whole power 2 by 3. We have a plus 5 of course. So 2xy, the function is correct, right? So 12,000 by xy plus y plus 5 of course. Then let's see, plus 5, p is equal to fx, which is equal to 2 plus this value 2 minus 1000 by y x square of course is equal to 0, correct? And q, because the values are appearing slightly strange, that's it. Okay, nothing apart from that. So let's see, q is equal to fy, which is 12,000 by x into minus 1 by y square plus 1 is equal to 0, correct? So from the first equation, what you can get is y is equal to, so you have, if you send it to the other side, so minus 2 and minus 2y, so 2 cancels 6000, minus gets cancelled, 6000 by x square 2, y equal to 6000 by x square. So if you put y is equal to 6000 by x square in this equation, you get 12,000 by x is equal to 12,000x into 1 by y square is equal to 1. So 12,000 is equal to x by xy square, right? It is xy square. So it is x into y square, and x into y square is 6000 square by x power 4. So if you simplify, 6000 cancels twice, 2 cancels 3000. So 3000 and x is equal to 0 is one solution, obviously. But x cannot be 0 because if x is 0, this is 0 by 0 form. So that's why we'll neglect this solution actually. So you will ignore this solution in this case. So if you ignore this solution, then what about this? X equal to cube root of 3000, correct? Because x cube minus 3000 equal to 0. So I think this calculation is correct, right? So equation power is 4, but roots only 2. This equation is not of fourth power, no, actually, right? This equation is not of fourth power, correct? When you equate this differentiation, you get only a second degree equation. And see, but for example, these are like you can see there is involvement of only 2 plus xy, so it's a cubic equation, of course. Like, but the roots are repeating. Okay, the roots can be repeating because we want to stay within the real plane actually. Okay, so x is equal to cube root of 3000. Then if you substitute these values, let's see what happens. R value, what is R? The second derivative of this function with respect to x, that gives you 2 minus, or derivative of this with respect to x is 0 minus 12,000 by y square, minus 12,000 by y into, this is x power minus 2, so minus 2 by x cube, minus 2 by x cube actually here. So this gets cancelled. So y is positive, x is positive, so this value is positive actually. Okay, so this value is positive because x cube is 3000, so this value is 4 of course. So 4 into 2, 8 by this value which is positive. What is RT minus S square? RT minus S square is, R is this, R is actually this value. Okay, so which we simplified, minus 12,000 by y into minus 2 by x cube. Okay, then what about t? Actually, t is the second derivative with respect to y. So minus 12,000 by x minus 12,000 by x into minus 2 by y cube. Okay, so this is minus 2 by y cube minus t square. Okay, RT minus S square. So what is x? Differentiate this with respect to y maybe. So if you differentiate it with respect to y, you have 12,000 by y square x square. So 12,000 by y square x square. So this is the function. Okay, and you have to figure out whether this function is positive or negative at this particular point, x equal to this and y equal to this point, of course. Okay, so let's do if this function is positive or negative. So if you place x cube is equal to 3000, of course x cube equal to 3000 is one solution. So x cube equal to 3000, this makes 4, so 8 by y into, okay, so this is 8 by y into, 8 by y into, this is 2400. But what about y cube actually? So y cube, so let's see, 1200 by x cube root of 3000, cube root of 3000 into 2 by y cube. So y cube is 6000 whole cube into the cube of this denominator is 3000 square. So 3000 square is what you get. Okay, so minus 1200 by root of y square is basically 6000 square into 3000 whole power 4 by 3, 3000 whole power 4 by 3 into x square. So what is x square term? 3000 whole power 2 by 3, 3000 whole power 2 by 3 is the x square term. So we have to figure out whether this value you replace y also better. This y you can replace with 6000 into 3000 whole power 2 by 3 again. Okay, so 3000 whole power 2 by 3. It's a slightly lengthy question. I think we can 3000 whole power 2 by 3. Maybe it's a very old question where conventional gate was conventional at long time back. Okay, so let's try to simplify this expression. So if you try to simplify this, so first of all, this value becomes 4 by 2 minus 2 by 3. So this becomes a 2, of course. Okay, and this square cancels this 2 times. So 2 into 3000 whole power 2 by 3 by 6000. Similarly, coming to here, let's say this 1 by 3 will cancel this 1 by 3, of course. Then this is 6000 will cancel this twice. Then this 3000 square will cancel this and we'll have a 4 here. 4 into 6000 is what we have. So 4 into 6000 into 300 power 1 by 3. Okay, so 2 4s are 8, 2 4s are 8, 8 2s are 16. 16 3000 power 1 by 3 by 4 times of 6000 actually here. Okay, so this value is 4, of course, minus this is 2 into 3000 power 2 by 3 by 6000. So the denominator is same, but what about the numerator? I think this is positive, of course, right? Because if you take 1 by 3 outside, then we have, so like if you take 1 by 3 outside, then we have 4 times, okay, 10 divided by 6000. 10 divided by 6000 because cube root of 1000 is 10. 4 into 3 power 1 by 3 minus 2 times of 3 to the power 2 by 3 into 10 square is actually what you have. Okay, so this is like 10 power 2 by 3. So you have one more 10, of course. So 20 times 3 power 2 by 3 clearly. Okay, so this value is negative in this case because obviously it's 3 power 2 by 3. The fraction is also 20, of course. Okay, so this is negative. So we have the maximum cost. Okay, so optimal is basically the spelling, I guess. So in this case, because x and y are the variables, I think there could be some issue in typing of this function maybe here. Okay, otherwise values are this range and normally a gate question won't be this long, to be frank. Okay, so if the function is correct, if it's depending on x and y, maybe some square is missing or something might be happening. Otherwise I don't think it could be this long. Okay, so maybe in the typing something happened. So let's see the total cost of an equipment in previous gate questions maybe. Okay, so let's see the total cost of an equipment. The total cost of an equipment actually. Okay, the total cost of an equipment get. So let's see if you calculate this, then we have so many questions, of course, but it's not there. Okay, so fine, it's okay. Maybe if there is some issue, I'll check it up. Okay, I'll check it and we'll see if there is any issue in this particular question. Okay, so for the time being, let's leave this question. Let's go to the next question because I'm sure because the gate question will not be this lengthy very. Okay, it's very highly lengthy. So let's do this question. So calculate this. The number of points at which the function x square by 2 plus y power 4 by 4 minus y square by 2 has local minima at number of points. Come on, solve this question. So anyway, this question we are not able to enter. So let's see integer type, and again I'll give you 3 minutes time maybe to work out. So please work out this question. 3 minutes. So solve this question actually. Because I'm sure gate question won't be that lengthy. Okay, because unless until something is missing, we are trying to maybe solve a wrong question. So please try to calculate this. The number of points at which the function f of x comma y is equal to x square by 2 plus y power 4 by 4 minus y square by 2 is dash. So do this. The number of points where the function has maximum, sorry, minimum, I guess. Okay, yeah, minimum. 1 is the answer. You have only one minimum, maybe. Let's check. Two, maybe. Let's check. Last 1 minute. Two. Okay, maybe let's check. Last 30 seconds. Quick. A bit fast. If questions are well, and then how to solve questions with 2 seconds by students? With 2 minutes, 2.5. Yeah, basically I thought there could be some issue. Okay, otherwise normally you can, like for example, you see this question, it can be solved in 2 minutes. Okay, so generally it's good. So let's see. Stop poll. Fine. So let's solve this question. So given f of x comma y is equal to x square by 2 plus y power 4 by 4 minus y square by 2 actually. Okay, so this is y square by 2, of course. So if this is y square by 2, this, just a second, I think here did we make any issue in the calculation? This calculation is correct, right? Nobody is willing to challenge this calculation, right? So we have x square. Yeah, everywhere the calculation is correct in this. 2 plus 12,000 by y into 1 minus x square is equal to 0. So that gives you, this is 6,000. Yeah, correct. So this is 6,000, of course. So 6,000, 2 cancel this 6,000 times 6,000 by minus 1 by x square is equal to 6,000. Yeah, that's 2. Yeah, this is correct. So yeah, I think this calculation is correct. Maybe there is some issue. Let's check it up later. Okay. So let's come here. So what is p actually? So this implies p, which is equal to fx, is differentiation of this function with respect to x is 2x by 2. Derivative of this term is 0. The derivative of second term is also 0. So equate this to 0. So we have x equal to 0. It's a straight solution. Okay. Then what about q? Q is equal to fy, and fy is equal to, so the derivative with respect to y is 4y power 4 by 4 minus 2y by 2 is equal to 0 actually here. Okay. So if you simplify this, 2 gets cancelled, 4 gets cancelled, of course, or else in general, if you try to simplify this, you have, yeah, y power 4 minus y is equal to 0 actually. So this tells you y cube minus 1 times y is equal to 0, of course. So y equal to 0 or y equal to 1, because you are going to stay in the L field, so that's why y equal to 1. Otherwise, having cube roots of unity, you would have got 1 omega, omega square, all these things. So what are the two stationary points? Let's check. So therefore, the stationary points are, what are the stationary points? So stationary points are origin. Okay, so 0 comma 0, of course. So let's see, 0 comma 0 is what you get, and one more point is 0 comma 1 actually. Okay, because you have x equal to 0, which is fixed in both the cases, and y equal to 0 and y equal to 1. So you get two stationary points actually in this case. Okay, so let's see at r. So what is r? R is the second derivative of this. So first derivative is 1. So second derivative, first derivative is x. So r is equal to 1, of course. Okay, differentiate this x with respect to x once again. So t, r s t. So s value is, differentiate this with respect to y. So it is 0. And what about t actually? T is, differentiate this with respect to y, gives you 4y cube minus 1 actually. Okay, So 4y cube minus 1 is the function. So what is RT minus S square? So RT minus S square is R into T. So 4y cube minus 1 minus S square. So S is 0. So at origin, clearly R is positive because R is positive in all cases. R is equal to 1 and RT minus S square. So if you check this, RT minus S square, if you put 0 comma 0 in this case, you get 4 times of 0 cube minus 1, so which is minus 1, so which is negative. So this implies 0 comma 0 is a maximum point, is a local maximum of course, and at 0 comma 1 R is positive. And what is RT minus S square in this case? So RT minus S square in this case is 4 times of 1 cube, 4 minus 1 which is 3, which is positive. So this implies 0 comma 1 is a minimum in this case. Okay, so this is minimum of course. So 0 comma 1 is a minimum. So you got 2 stationary points, and out of these 2 stationary points, at one case only you have the minimum. So out of these 2 stationary points, you have only the minimum at one stationary point of course. Okay, so you have this at one stationary point. Clear? And what is the minimum value? If you check, minimum value is equal to, so if you simplify, it's 0 and 0. If you cancel, you get 1 by 4 to at x equal, 0 comma 1. So if you put 0 and 1 here, 1 by 4 minus 1 by 2, which is minus 1 by 4. Minimum value is 1 by 4. At 0 comma 0, this function is 0. That's the maximum. So the value lies between 0 and 1 by 4 of course. Okay. Normally in some cases, not in this case, but in general in few cases, you can model the function. Like let's say if I give you x square plus 2xy plus y square, okay, then you can write that function as x plus y whole square, so that you ultimately know the minimum value is 0. Okay, so because it's a square of a real part. So in such cases, in few cases, we can identify the functions, but in general, if functions are not identified, this is the general procedure to work out. Okay, now let's go to one more concept actually. So this is the case when there is no restrictions on the functions. Okay, now let's go to a case of unconstrained maxima and minima of course. Okay, so let's do that. Constrained maxima and minima. Okay, so constrained maxima and minima, it's also called as method of Lagrange's multipliers. Method of Lagrange's multipliers. Okay, so method of Lagrange's multipliers. So this is again a bit important. Now let's see. In general, if I ask you this question, what is the value of x square plus y square plus z square, where x, y, z are real numbers? So these are real numbers. Let's say I have given you these are real numbers of course. Then what is the minimum value of this function? So can someone tell me what is the minimum value of this function if x, y, z are real numbers? If x, y, z are real numbers, then what's the minimum value of this function? What is the minimum value of that function? Can anyone quickly tell? Come on, type it in the chat box. What is the minimum value of this function? I'm telling you x, y, z belongs to real numbers. So what is the minimum value? Can anyone tell me? You can think actually, okay? We can't say, oh my God. Correct? Apart from x equal to 0, y equal to 0 and z equal to 0, if you replace any other value, yeah, correct Himbindu, the answer is 0 of course. Okay, because apart from the values of x equal to 0, y equal to 0 and z equal to 0, if you try to keep any other values, ultimately this function is non-zero and it gives you some positive value. Okay, so that's why this is 0. But let's say if I put a restriction on this time I'm not putting it, asking it, I'm putting one restriction. Minimum value of this function when there is a restriction on these variables x plus y plus z is equal to 1. So in this case, can someone tell me what is the minimum value? Now Now you cannot put x equal to 0 and y equal to 0 and z equal to 0, because if you put x, y, z equal to 0, this summation is not going to be 1. Okay. So in that case, now can someone tell me what is the minimum value in this case? What is the minimum value? So which chapter to start with for math if you want to begin? You can start with calculus, single variable calculus. Okay. Or basically first, to be honest, to be really, you can start with 11th and 12th NCERT books so that you can start building up some nice basics. Then you can quickly call on to the engineering concepts. Okay. So can someone tell me what is the minimum value in that case? Matrix. You can start with matrices also, no issue. Okay, but in general, matrices is something like, sorry, in exams, what is difficult problems such as elliptic problems which you have solved in linear algebra pops up all of a sudden. How do we go from to advanced like you? Just you can practice the questions. Okay, it happened once when IISc has organized GATE exam in 2016, but in general, yeah, I remember the ellipse problem, major axis, minor axis question you're asking about, x plus 3y something. Okay, as far as I remember. So you can just practice PYQs and be in touch with all the concepts. Then you will be able to solve that, no issues. Okay, so let's see. So the correct answer for this is actually 1 by 3. Okay, you will see why this is 1 by 3. Just a second. So let's start the common theory for this. If f of xyz, if f of xyz is the function to be optimized, and x, y, z are connected by the constraint, phi of x, y, z is equal to constant. Okay, then how to deal with this? Okay, so basically what my main sense here is to tell you, you want to optimize this function, but previously you do not have this restriction on the variables. Okay, so x, y, z can take any values literally, but sometimes you may have a restriction. Okay, let's say for example, if I want to make a box physically, okay, I'm just giving some physical examples, but I have a limited material. When material is limited, ultimately the surface area of that block of that box is fixed. Yes or no? Because wherever you want to make a surface, ultimately whatever the shape you make, you have the same amount of material, so you have same amount of you have same amount of surface area. Then ultimately you can make different volumes, but what is the maximum possible volume you can make? Okay, so if questions comes like this in general, okay, or if you have some volume of a substance, okay, so with that volume, what is the shape you can make so that you have the minimum surface area? Okay, do anyone know in general? If you have some volume of a material and if you want to make a solid with that material, what is the solid which gives you the minimum surface area? Any idea? If you have some volume of a material and if you make, let's say, a cuboid, cylinder, rectangle, prism, sphere, whatever you make different solids. Out of all these solids, do you know which solid will have the minimum surface area or the least surface area? Sphere. Yeah, good. Okay, so sphere will have the minimum surface area, of course, and that's why actually the phenomena of, normally if you talk about things like surface tension and all, the raindrops, all these things will be spherical. Normally if you leave a droplet, it tries to achieve minimum surface area, so it eventually gets into a spherical shape. Okay, if you just spill some water on the floor, it becomes spherical in shape after some time. Okay, so anyway, let's see. So when you have such constraints, okay, so physically these variables are actually connected, then how to calculate the maxima and minima? Let's see this. So step one, form a function, capital F of xyz is equal to small f of xyz plus lambda times of phi of xyz minus constant. Okay, so let's form this function. C is some constant. Okay, these three are connected by some equation actually. So form this function. Step 2, again the second derivative. Step 2, consider the equations, and this lambda here, which I forgot to tell you, this lambda here is called It's a multiplier to this function, so it's called Lagrange's multiplier because this method was initially given by him. So Lagrange's multiplier. That's why it's also called as method of Lagrange's multipliers. Okay, so this lambda is called the Lagrange's multiplier. So when will you begin matrix? I have already finished matrices, of course. Okay, in the 1.2 lectures, you can just refer Kunj. So let's see. Consider the equations. Dou f by dou x is equal to 0. Dou f by dou y is equal to 0, and dou f by dou z is equal to 0 actually here. Okay, so dou f by dou x, dou f by dou y, and also dou f by dou z is equal to 0. Then from these equations, obtain the relation between the variables x, y, and z. Obtain the relation between the variables x, y, and z actually here. Now the step 3 you will go for is substitute the relation between x, y, z. Substitute the relation between x, y, and z in phi of x, y, z is equal to constant. Okay, so substitute this relation in phi of x, y, z is equal to constant actually, and get the optimal values of x, y, and z, and get the optimal values of x, y, z. Let it be x naught, y naught, z naught. Let it be x naught, y naught, z naught actually here. So this tells you the optimal value is f of x naught, y naught, and z naught, obviously. Okay, so this is the optimal value that you have here. Okay, now here if you observe one thing, this method of Lagrange's multipliers do not give you the nature of this optimal point. Okay, so that's one main drawback in this. In case of method of Lagrange's multipliers, you can get the optimal value by differentiating this to 0, then getting the value, but you do not know whether this value is minimum or maximum. It generally depends upon the physics of the problem, in fact. Okay, so like if you want to have a minimum surface area, then with the maximum volume, that gives you the maximum. Or if you have a fixed volume and if you're trying to calculate the minimum surface area, then this optimal point is for the minimum surface area calculation. So all these things will depend on physics, but in general this is the working procedure. Okay, so I'll write here the main drawback of method of Lagrange's multipliers is it do not specify the nature of the singular point. It do not specify the nature of the singular point actually. Okay, so singular point, clear? So that's the main drawback in this case. The nature of the singular point comes out from the physics of the problem actually. Okay, in general. So let's see example. I'll work an example so that you can have an idea. So let's say if the maximum value or the minimum value of x square plus y square plus z square, let's say when x plus y plus z is equal to a. So let's say I have put some restriction on this xyz variable such that the sum has to be a constant always. Okay, so this sum is always a constant, means whatever the variations you put in xyz, the variation should be in such a way that this summation is always a constant value which is equal to a. Okay, and let's figure out what is the minimum value in such case when x plus y plus z is a. Like in the previous case I have given a equal to 1. So let's see how it comes up. So let's follow this procedure, the standard working procedure, step by step. So first form this function. So solution, step 1, let f of xyz is equal to the function which is to be optimized is this function, and the constraint equation is this equation. Okay, so this is the constraint equation which I can maybe write it here. So this is a constraint equation. Okay, so let's see, first of all form this auxiliary function. So the function to be optimized, x square plus y square plus z square plus lambda times of this function, which is the constraint function, x plus y plus z minus a, of course. Okay, so this is the function actually. So step 2, calculate the first derivative is equal to 0. Okay, so consider dou f by dou x is equal to 0, dou f by dou y is equal to 0, and dou f by dou z is also equal to 0 actually here. Okay, so if you calculate this first function, dou f by dou x equal to 0, so differentiating this complete function with respect to x partially gives you derivative of this x square is 2x, derivative of y square with respect to x 0, z square with respect to x 0 plus lambda is what we have. So plus lambda is equal to 0 actually. Similarly, this equation gives you 2y plus lambda is equal to 0 and 2z plus lambda equal to 0, which means you can observe something. Lambda is equal to minus 2x, lambda is equal to minus 2y, and lambda is equal to minus 2z actually here. Okay, so this is minus 2z. So which tells you now, once you get this, this is value of lambda, this is also value of lambda, and this is also value of lambda, which means you can equate this all three lambdas. So this implies minus 2x is equal to minus 2y is equal to minus 2z. So ultimately, if you cancel this minus 2 all over, you end up with a relation x is equal to y is equal to z. Means the condition or the relation between x, y, and z when this function is going to be optimal is when all three variables take the same value. Okay, so when this x, y, z, all these guys are same, only in such case this the first derivative being 0 gets validated and you have this function. Okay, now that's what I have mentioned here. By equating lambdas from different values, you can see, consider these three equations to be 0, obtain the relation between the variables x, y, and z, of course. Okay, so now you got the relation. Now go to the next point. Substitute the relation between x, y, z in this function and get the values of x, y, z. So till this point, you just got the relation between the variables, but you didn't get the values of x, y, z. Okay, so who gives you the values of x, y, z? Definitely this x, y, and z should satisfy this constraint equation. Correct? So substituting x is equal to y is equal to z in the constraint equation, which is x plus y plus z is equal to a. So this implies, so if you put x equal to y equal to z, you'll get x equal to y equal to z is equal to a by 3 actually here. Okay, so this is a by 3. So now you got the values of x, y, z. Previously till this point you just got the relation, but by substituting this relation in this constraint equation, you have got the values actually here. Okay, so this is the optimal value, which is x equal to a by 3, y equal to a by 3, and z is equal to a by 3 actually. Okay, so what is the minimum value? Therefore minimum value is, you know, maybe I'll put a line here and we'll write. So therefore minimum value is equal to x square plus y square plus z square at x equal to a by 3, y is equal to a by 3, and z is also equal to a by 3 actually. So if you put these three values, you'll get 3 times of a square by 9, of course. So the value is a square by 3. So therefore minimum value in this case is going to be a square by 3, of course. And if your value of a equal to 1, this value is 1 by 3. That's it. Okay, so you take any values of x, y, z apart from, let's say for example, if I give x plus y plus z is equal to 3, okay, then the minimum value of this is also 3 square by 3, which is 3. Like if you want to put x plus y plus z equal to 3, you try any values apart from 1, 1, 1, you will get the answer more than 3 actually. Okay, clear to all of you? So is this clear to each and everyone? Did you all understand this example, how we have worked out? Following the procedure step by step. Okay, everyone, Alex, Arvind, Kunj, Shravan, Ashwini, Pajwal, I could read only these names, the rest all got escaped. So please type it in the chat box. Is this clear to all of you? Did you all get this? When x plus y plus z equal to, for example, you take a equal to 3. Apart from the values, if you put x equal to 1, y equal to 1, and z equal to 1, if you try to keep any other variables such that x plus y plus z equal to 3, the value of x square plus y square plus z square would be definitely more than 3 actually in such case. Okay, fine. So this is basically the idea. So I'll give you one more question. Just try it as homework for the upcoming class because it's already time today. the value of or the minimum value of xyz, the minimum value of x, y, z if x plus y plus z is equal to say 9, let's say. Okay, so if I give you 9 or 3, let's say, for example, the same thing, 3. Okay, so homework is dash. So think a bit about it. So it's a homework question, and also I'll give you one more homework question actually. So this question is also homework. Okay, the distance between the origin and the point nearest on the surface, nearest to it on the surface, z square is equal to 1 plus xy. So z square is equal to 1 plus xy is what we had. So we need get mentorship session back again. Okay, I'll come back, no issues. Okay, so maybe on YouTube we'll do this in the upcoming week. Okay, we can, no issue, we can, because I'm always here, you can ask me as many points as you want, just I'm giving a hint. Okay, so good. So only one question we have faced issue is basically this optimal question. I think there's something missing, otherwise this big calculations won't be coming. Okay, or else maybe that question is during the time of GATE being conventional exam. One of these things might have happened. So let's check it. Okay, anyway. So let's see. In today's class, we discussed about the maxima and minima. First of all, unconstrained minima, which is unconstrained. In general, we have seen the working procedure for that. So we have seen the saddle points, all these things. Then constrained maxima and minima. Okay, so constrained maxima and minima, of course, or the Lagrange's multipliers. We have also talked about this. Okay, so Lagrange's multipliers actually. Okay, so these are the things which I have talked. So in Monday's class, of course, after solving these homework questions, we will go to the multiple integrals actually. Okay, so which is very nice concept actually. If you come, I'll show you some geometrical, again some geometrical interferences and all, but please don't miss that. Okay, the reason for that is many of your technical questions, okay, many of the integrals which come in your technical core subjects, that we will able to solve very easily once you understand this concept of double integration and triple integration. Okay, so don't miss those sessions. And again, we'll meet on Monday. We'll meet on Monday actually at 7 p.m. and till then I'll take a leave from you. Okay, so if you have any doubts, you can ask. No, actually multiple integrals is easy. Okay, the reason why many of you feel it terrible is you won't understand it as that particular concept. Okay, so that's all. I have doubts in some basics. Could you please explain in the definition of neighborhood A? Do we also consider A in neighborhood? We consider A in neighborhood actually, but limits are always defined on deleted neighborhood. I have mentioned this point very clearly. Deleted neighborhood is basically from the neighborhood set we delete A actually. Okay, and the limit is always defined on the deleted neighborhood. We never put x is exactly equal to A in when you are writing limit. Okay, so it's defined on the deleted neighborhood. Okay, in continuity topic, limit exists but not equal to functional value. Is this possible? Yeah, we have seen many cases, right? Limit exists but the function is not exist. Like if you take simple like 1 by x. Okay, limit x tends to 0, 1 by x. In one case it's a very large number, and in another case it's a very small number, but exactly at x equal to 0 it does not exist. Okay, like similarly if you take mod x function, okay, the derivative of mod x is mod x by x. In the right limit it's +1, in the left limit it's -1, so limit does not exist, and at x equal to 0 it's 0 by 0 division. So there are many examples in which we have solved in class. Okay, sin x by x, so limit x tends to 0, sin x by x is 1, so limit exists, but exactly at x equal to 0, sin 0 by 0, it's a 0 by 0 form, so indeterminate. So you have a lot of examples which we have dealt in the class itself. Okay, Lagrange's formula. Basically in differentiation we have seen the Lagrange's mean value theorem, where f dash of c is f of b minus f of a by b minus a, which is the last lecture of the 1.0. If you want, you can just visit back. So the last lecture of 1.0 is where I have dealt the Lagrange's mean value theorem, LMVT. Okay, so just have a look. I'm concerned about my performance in GATE, sir, getting anxious day by day. In the last lecture, I have, okay, I'll do one mentorship session as well. So on this same channel, hopefully in the next week we'll do. So please make a consistent preparation using that. Okay, so that would be helpful. So 12th result 54%. मैं कौन सा IIT मिलेगा CSC branch में? It depends. Okay, again, please work out your BTech. 12% really doesn't matter for getting admission to BTech. Only thing that matters is your for BTech. Okay, can you please CSC branch milega in BTech? It's no issue. Just focus well for JEE mains and advanced. Okay. If your performance is really good in JEE advanced, you will be offered some good IITs like in the old 7 IITs, and also if you want to do BTech in computing and maths, IISc has also opened that. Okay, so you can check. Yeah, as far as possible, whatever the graphs functions we are drawing, those are our applications, of course. Okay, it's not like a pure math. Fine. So thank you all. We'll meet on Monday at 7 p.m. again. Yeah. Okay, and we'll start the concept of multiple integrals. Yes. So how much time is required in per day for complete GATE syllabus? It doesn't matter. It depends on your capability. In the beginning, you may take large times, but as time progresses, you can cut short the time, of course. सर 54% में कौन कौन सा IIT मिलेगा CSC ब्रांच में अगर मेरा गेट में अच्छा रैंक आया तो MTech? See, for MTech admission, it's purely based on, again, your only GATE score. Okay, that's it. Like for example, if you get All India first, and if you want to go to really CSC, and if you want to come to IISc or IIT Bombay, you can get, obviously. Why not? Okay, the only thing it matters is like the entrance test rank. Okay, that's it. Not able to write big messages. It's okay. In this Telegram channel, you can communicate. No issue. So this is the Telegram channel. As I have put forward, you can communicate here. Okay, scan this. Then ultimately you'll get joined into the group. There you can communicate. Okay, no issue at all. Fine. So I hope things are clear. Then don't worry. I'll try to take one mentorship session the upcoming week, hopefully, so that all of your questions and all can be cleared. Okay. So I need help. I'm 2023 graduate, currently in company, but feel like stuck. No issue. You can just text me there. Okay. In that group, all of our friends, we have almost some 1500 friends in that. Definitely we are at your help. Okay, Piyush, don't worry. So thank you all. We'll meet on